Alright, so now that we've kind of refreshed on what proportional and non-proportional are, we're going to have some different terms for that this year as we get closer to algebra, and we're going to start talking it in direct variation. So direct variation, what that means is the relationship is proportional. So anything that was true for a proportional relationship is also going to be true for direct variation. So the graph is still going to go through the origin. We're still going to have that constant variation. It's still going to look multiplicative if we're taking it way back to what we learned and talked about a couple years ago. So everything that's true for proportional is also true for direct variation. Couple things that we want to talk about that are slightly different but not really too different. First thing is the constant of variation. You might remember this as the constant of proportionality. We're going to find this by doing y over x, and that's going to give us our k, and k cannot equal 0. So there's certain numbers that we can't use for this. What I'm going to do is I'm going to hop down to this table and kind of show you what that's going to look like and how we're going to find it. When I think of the constant of variation, I like to think we're looking inside the table. If we go rate of change, we're looking delta y, delta x, and that's outside, and this is different than that because I'm using the values that are actually in the table. I'm going to take this y and I'm going to divide it by its x. So if I was doing it out to the side, I'd say give me -1 divided by 2, right? Or -2, excuse me. And when I do that, that gives me +1/2 or 0.5, right? Now, if it's a proportional relationship or if it's a direct variation, as we're calling it, this constant of variation should be the same throughout the whole table. So let's check it. If I do -1/2 divided by -1, so I have -1/2 divided by -1, well, anything divided by 1 is itself, and since I have two negatives, that's also going to give me 0.5. So already I can see they're matching. Now remember I said I can't use 0, so I'm going to skip over this 0 line, but double 0 should tell you that that goes to the origin and that's proportional. Let's go down, I'm going to skip and just do this last one here as well. So I have y, my number 1, divided by x, so 1 divided by 2 is also going to get me 0.5. So what we should be able to see here is that all of these numbers are the same. Since that constant exists, that's why this is a direct variation, right? Or a proportional, as we used to call it, relationship. Now, once I have that number, I can do something else with that. I can look at writing my equation. So since I know that this is a proportional relationship, I can use that k, and what I found here, this 0.5, I'm going to put in for my coefficient. So I can write the equation of y equals 0.5x, or if I wanted to keep it as a fraction, I could write 1/2 x. And so that's what we're looking at there. So everything that's true for our proportional relationships is still true for direct variations. We just kind of have a new name for some things. And that's really it. So a big thing we want to make sure that we know you can do is if you have the table, you can use that k and you can use that information to find your coefficient and then write your equation.